Okay, in working through our review, just as a reminder, you will have to turn in the L'Hopital multiple choice, which there are 18 multiple choice questions in your packet. 18 multiple choice questions. You will also have to turn in the 5 linear approximation questions that were multiple choice from that packet. Make sure your name is on the packet if you're going to turn the entire packet in. If you pull out the pages, you have to put your name on the pages. Otherwise, you will not receive credit. Okay, now on to our review. A circle is inscribed in a square. Okay, so if we're looking at what that information means, in order for the circle to be inscribed, these points have to be tangent so that the diameter of the circle is actually the same length as the side of the square. So we can call both of them D. Now it asked us to find the rate at which the diameter of the circle is increasing. The given information says that the circumference of the circle is increasing, so the rate of circumference over time is going to be positive, 6 inches per second. We have 2 choices for circumference of a circle. Neither one of these equations will be given to you. You have to know circumference is 2 pi r or pi d. Now, if I take the derivative of the diameter version, that would read the derivative of circumference with respect to time is pi times the derivative of diameter with respect to time. Substituting into that equation 6 for the change in circumference equals pi times the change in diameter. I then divide by pi so that the change in diameter over time is 6 divided by pi. The units are diameter over time, which means inches, and in this particular problem, time is in seconds. Do not allow pi to magically levitate to the top of your fraction. The next part of this question asked us to find the rate at which the perimeter of the square is increasing. We have to know that perimeter of a square, without being given the formula, is the sum of the 4 equal sides, or 4d. Taking the derivative to find the rate, I get derivative of p with respect to time is 4 times the derivative of diameter with respect to time. The derivative of p with respect to time is then 4, and I can substitute the previous value into this equation. So I have 6 over pi, so that gives me 24 divided by pi. Perimeter is still measured in inches, and time is still measured in seconds. Again, do not allow pi to levitate into the numerator of your fraction. Using this same information at the instant when the area of the circle is 25 square inches. And what that is telling us is that the area, which we have to know without being given, is pi r squared. So I can substitute the 25 pi into the area equation for a circle and get 5 for the radius at that particular time, still in inches. Find the rate of increase in the area enclosed between the circle and the square. Well, the enclosed area is the square minus the circle. So if we go up to look at that, the shaded area we're referring to, or the enclosed area, will be the part outside the circle, but still inside the square. Okay, so we're trying to get, I'll call it E for enclosed, the rate of change of E. So I'm going to write the formula for that. The square has an area of D times D, or D squared, side times side. The circle is still pi r squared. Since none of what we have prior to this is in terms of r, but in terms of d, we're going to need to get a relationship for that. So when we do the derivative of the enclosed area with respect to time is 2d times the derivative of diameter with respect to time minus 2 pi r times the derivative of r with respect to time. Now, we know a relationship between diameter and radius. The relationship between diameter and radius as diameter is 2 radii. So if I take the derivative of that, the derivative of diameter with respect to time is equal to 2 times the derivative of radius with respect to time. Since I know the derivative of diameter is 6 over pi, I can substitute that in, and 6 over pi equals 2 times the change in radius. Dividing both sides or multiplying both sides by a half, dividing by 2, I then get 3 over pi inches per second is equal to the change in radius over time. Okay, so for this equation, we're going to need to know both the change in diameter, which we have, the change in radius, which we have, the radius, which we found, and the diameter, which we now know is the radius is 5 inches, the diameter is 10 inches. To finish out the problem, the change in enclosed space with respect to time is 2 times the 10 diameter times the change in diameter, which is 6 over pi, minus 2 pi times the r, which is 5, times the change in r, which is 3 over pi. So the derivative of the enclosed area with respect to time is 120 over pi minus 30 without the pi's because those actually cancel. Now, this is all measured as enclosed area. So enclosed area is inches squared. Time is still seconds. Okay, this problem asks us to know, did not give us the formula this year, the volume of a prism. Okay, this prism actually has a base that's a rectangle. Sorry, a triangle, not a rectangle. Base is a triangle, and the length is the length of the trough. So the volume of any prism is the area of the base, the parallel bases, which in this case again are triangles, times the height if it were standing on edge. Okay, so for in this case, the volume is the triangle 1/2 triangle base times triangle height times, and in this case, our h we'll call L, because it's actually the length of the trough. So finding the overall volume was impossible if you didn't know how to find the volume of a prism. Volume is equal to 1/2 the base of the triangle, which is 2, the height of the triangle, which is 3, and the length where the water is going across, which is 5. So we end up with 15 cubic feet. Now, the next part asks us for the rate of change in H at the instant when the trough is a quarter full by volume. So on here, we have water in the trough, but only a quarter full. That means a quarter, not height, but a quarter full by volume. Okay, in the paragraph, it tells us that the volume is being siphoned out at a rate of 2 cubic feet per minute. So it's actually telling us the change in volume over time is a negative 2 cubic feet per minute. So when the trough is a quarter full by volume is going to be something we actually deal with after we take the rate of change. One thing we want to notice about this, regardless of how much water is in the trough, the length of the water in the trough never changes. What does change are the proportional triangles. So volume is equal to 1/2 base of the triangle, height of the triangle, length of the trough. The ratio of the base over the height is 2/3. So the base of the water divided by the height of the water is going to be 2/3 so that it matches the container. Since they're asking me about H, I'm going to get rid of B. B equals 2/3 H. I'm going to substitute that into my volume equation. I'm also going to recognize that the L in the picture, which is 5 feet, is actually fixed. That's the only part of the water that does not change, so I can substitute a constant 5 in. In order to avoid the product rule, because we do have a product right there in the center, I'm going to simplify first. So the volume is 5/3 H squared. Finding the rate, the derivative of volume with respect to time is now 10/3 h times dH dt. We know dV, they're asking us for dH, and we know that the trough is a quarter full. We're going to use that quarter full in order to find the h. I'm also going to use the simplified version of volume instead of the harder version. So I'm going to use the 5/3 h squared. So a quarter full by volume, if 15 cubic feet is full, then a quarter full is 15/4. I can then multiply by the reciprocal and get 9/4 is equal to h squared. So h has to be 3/2 of a foot when the trough is a quarter full by volume. I can now substitute that back in to my equation with the change in volume, remember, is being siphoned out, so it's a -2 equal to 10/3 h dH dt. So -2 equals 5 dH dt. That means that the change in height with respect to time is -2/5. This is height over time, so it is feet, and in this problem, time is in minutes. The last part then asks us what is the rate of change of area of the surface of the water that would be shaded in the picture. So what they're talking about is not the surface area of that crazy prism, they're just talking about this exposed part, the water that's going to be touching the air that we can see here. So on that case, we only have, for that area, the base of the water for the triangle, so just the base of the triangle, not the height, and then this fixed length, which is still just 5. So when we're talking about the area is just base times 5. We could substitute out still that the base is 2/3 the height. So the simplified version of area is that 10/3 times h is the surface area of the water. So now the rate of change is the derivative. So dA dt equals 10/3 times dH dt. We already know dH dt from part B, so we can substitute that in, the -2/5. So that makes -20/15, or -4/3. And area would be measured in feet squared, and again, time is still measured in minutes. Remember that at any time you can pause the lesson, write notes, rewind, or start over. Okay, a graph of a differentiable function on the closed interval is given as f. It gives us information about f, that it has a horizontal tangent at x equals 6. So basically they're telling us that f prime of 6 is 0. Okay, remember on here that the graph is of f, not of g. So we're going to skip down and look at what we're asking for here. Okay, g is defined by this integral. So if we're looking for g of 6, we're looking for 5 plus the integral from 6 to 6, f of t dt. So I'm basically substituting into the equation where the x used to be. So that means that I have 5 plus the integral from 0 to 0 is just, from 6 to 6 is just 0, so we have 5. There are no units, therefore you should not make up units. Now, in order to find g prime and g double prime, I have to take the derivative of g. So using the defined function for g of x, g prime of x is the derivative of 5, which is 0, plus using the fundamental theorem part 1, the derivative of an integral cancels. I substitute x in for t, which means the derivative of x is in dt. So basically, remember, we're going to sub in x is going to go in place of t, which means 1 is going to go in the place of dt. So g prime of 6 is just f of 6. F of 6 is on the graph of f at 6. So before we were getting the area by substituting n. This time we're not substituting into the integral, we're just getting the graph of f value. So f of 6. And f of 6 is 3. Now, using g prime, I will get g double prime of x. So the derivative of g prime is g double prime, which is the derivative of f, so f prime. That means that g double prime of 6 is equal to f prime of 6. Since they told us that f has a 0 slope or a horizontal slope at 6, we already had that value written down, which makes this 0. So the second derivative is 0. The first derivative was 3, and we actually know the y value for g. On g, we have the 0.65. X is 6, the y value is 5. So now the next part says, on what intervals is g decreasing? This is the part that's really important that you ignore the graph. Write down your reasons. G is decreasing because g prime is less than 0. For part C, g is concave down because g double prime is less than 0. We can then ignore the graph, look at what we wrote in part A. We wrote that g prime of x is equal to f of x. So we're actually looking at the y values of the graph. So if we go back up and look at the y values of the graph, where are the y values of the graph negative? That occurs between -3 and 0, and between 12 and 15. Similarly, we're going to compare what we wrote for part A to do part C. The second derivative of g is less than 0. Since the second derivative of g is equal to f prime of x, those are the slopes of the given graph. So I want the slopes of the given graph to be negative. And the slopes of this graph are negative between 6 and 15. The last part is completely unrelated to the g information. Separate question, basically. Find a trapezoidal approximation from -3 to 15 of the area. So we are not going back and adding the 5. This has nothing to do with the question above that's talking about g being defined as 5 plus the integral. It just says find the area from -3 to 15 using the trapezoid approximation, equal length, width of 3. So what we're going to do with the trapezoidal, width of 3 means we're going to have 6 of them, just like it says. And we have to use every value. So we have to do 1/2 our delta t, which they told us is 3, 1 of the first, which is -1, and we can look at our graph, double all the middles, and 1 of the last point. So again, we're doing 1 of each endpoint because they're fixed delta x's. You may also do each and every trapezoid separately, 1/2, 3, left and right, each one separately. Or you can do the method, this only works because they're of equal length. If they're not of equal length, you can't use this method. So I have 3/2, -1, plus 2 times 5, plus another -1. So 3/2. And we have basically have 10 minus 2, so 8. So the answer is 12. However, remember, look how many points this problem is worth. 1 point for the trapezoidal method. You can stop here and still get the full point. Okay. For this question, we are also doing the fundamental theorem of calculus, but on the previous question, they told us we were starting at 6 and going across, so that was a completely different situation, because this one, they're not quite spelling it out for us, but when they give us an initial value at 0, that really means we're starting at 0. So what that really means is that our integral for f of x is equal to 3 plus the area from 0 to x, f prime, like so. Because if I substitute 0 in, I should get 3. So my starting point is where the initial value starts. So it's initial value plus change. So I have to start at 0. Okay. Now, ignoring what the graph says, because that's the most common mistake, on what intervals is f increasing? F is increasing because f prime is greater than 0. For the next part, find the x-coordinate of each point of inflection of the graph of f. Points of inflection occur because f double prime changes signs. Find an equation for the line tangent to the graph of f at the point 0, 3. The equation of a tangent line to the graph of f at the point 0, 3 means that we need f prime of 0 to be our slope, and then we're going to do point slope form. The last part says to find f of negative 3 and f of 4. So that means that f of negative 3 is equal to the initial value plus the change, where we're starting at time 0, because time 0 is where we have the initial value, and integrating f prime from 0 to negative 3. F of 4 is then 3 plus the integral from 0 to 4, f prime of x dx. We'll have to figure out how to get those areas. Now that we know what we're looking for, let's go back up to the top. Now, looking at what we have marked here, notice that it says we have the graph of f prime. So I immediately want to mark down for myself that f prime are the y values. That means f double prime are the slopes of this graph, and f is going to be the area, but we want to make sure we consider that initial value. Okay. Since we're looking for f prime, we're going to row back up here and notice that f prime are the y values, not the slope. So the y values, I will do an f prime number line. The y values between negative 3 and negative 2 are positive. From negative 2 all the way over to positive 2, the y values are negative. And then from positive 2 to positive 4, the y values are still negative. So even though we touch the x-axis, we don't actually cross and change signs. So on what intervals is f increasing, where f prime is greater than 0, the correct answer is negative 3 to negative 2. We have our number line to justify, and we have the right reason down. No answers without reasons. Okay, the next part says we're going to look for the second derivative. We're going to go back up and remind ourselves the second derivative are the slopes. So I'm going to do a second derivative number line, and from negative 3, x is negative 3 to x is 0. A lot of people want to do negative 3 to negative 2 because the y value is negative 2, but it's x is negative 3 to x is 0. We have a negative slope. From x is 0 to x is 2, we have a positive slope. And from x is 2 to x is 4, we have a negative slope again. So the second derivative, which are the slopes of this graph, are negative, positive, and negative. So we have points of inflection at x equal to 0 and 2. Okay, for the next part, we're actually looking for equation of the tangent line of f. So we need f prime at 0. So remember, as we go back up, f prime is the y values of this graph. So f prime at 0, the y values at 0 are negative 2. So f prime of 0 equals negative 2. So using the point and the slope. So y minus 3 equals negative 2, x minus 0. Now the last part is actually the trickier part of this, because we have to remember that when we're doing the area of this graph, because this part is backwards, because we're doing backwards from 0 to negative 3, this actually has to change signs. So we're actually doing the opposite of negative 3 to 0. So 3 minus, and now we can go up and do the geometry to get this part. So if I go up just to get the geometry from negative 3 to 0, I'm going to go up and look at this. So this triangle is 1/2 base times height, so it's actually a half. The larger triangle is also 1/2 base times height, so it's a 2. Because the half is above the x-axis, it's positive. The 2 is below, that's a negative. So I'm going to substitute that in as a half minus 2. And we are going to take care of the backwards because we factored this negative out. Okay, so we have the negative factored out. So we're doing the opposite of what we would have done. So you want to write this integral out so that you remember to do the opposite. So it's actually 3 minus a half and plus 2. So most of us would write that as 5 minus a half, so it would be 4.5. Remember that technically it's a non-calculated question. You could stop as long as you remember that negative sign in front. Okay, now, the trickiest part of this question comes from this next piece. This equation is in the correct order. We do not have to flip anything. So it's actually going to be 3 plus the geometry that we need here. It's the geometry for this piece that's a little tricky. We're looking for the area that's bounded, so we're actually looking for the area here between the x-axis and the curve. I would think of this as a rectangle minus half a circle. So the rectangle has an area of length times width, which is 4 times 2, or 8. Half of the circle has an area of 1/2 pi r squared, and the radius is 2, so that's 4 pi. So technically, if we just looked at this area off on the side, the area for the rectangle minus half of a circle would be 8 minus 2 pi. That's just the area. The problem is that this area is under the x-axis. So the area under the x-axis is negative. So we have to do the opposite of that area because it's below the x-axis. So this actually becomes negative 8 and plus 2 pi. So it's actually 5 plus 2 pi because of the original 3. Okay, now, on this type of question, remember you are never, ever allowed to write calculator notation anywhere ever in the answers of your work. Okay, the tank originally contains 8 gallons of oil. Okay, so we do have an initial value. It's not empty. We want to make sure on our calculator that we do this for 0 to 12 hours, that we are not looking at anything else. We will have to set our window and zoom 0. Okay, now, the next thing that we're going to do is for ourselves, at the top of the paper, we are allowed to write down where we put these functions. So y1 and y2. I would also make a note on the side that the first part says the heating oil is pumped into the tank. at this rate, notice it's gallons per hour, not gallons. So this is my rate N, and at the same time we're having some removed, we're using it up, so a rate out. I'm then going to put those values into my calculator. When I put them in, I want to make sure that I'm actually doing this so that I use the fraction features on the new calculator. It's harder to do if you don't use the fraction features. So when I put my functions into the calculator, I want to make sure that I'm putting them in with the correct format. So make sure if you have the old calculator, you are putting parentheses everywhere you would need them. So I put the parentheses in here for emphasis. Okay, now, how many gallons of oil are pumped in? So you need gallons, not gallons per hour. So substituting into the equation is not going to give you the right answer because that's gallons per hour. We only want what's pumped in during this interval. That means we are absolutely not including the initial 125, and we're only doing the rate in, not the rate out. So I need to write the integral. Please do not copy down everything that h of t is defined as. Please use as little time as possible for this part. So the rate n is h of t. You do not have to copy the function. Just write the integral from 0 to 12, h of t dt. You are then going to use your calculator to get the answer for that. Okay, so on my calculator, evaluating, I get this value. And I remembered that I stored it into Y1, but Y1 is not part of my work. So I want to double check, does this tell me to round off? No. That means it absolutely has to be to 3 decimal places, truncated or rounded. You absolutely have to put units. It asks how many gallons, so you need to tell me that you have that 70.571 gallons. Okay, the next part of this question is the most commonly missed part of the question. Most students want to tell me that they found out that I have integrated and I have oil in the tank, therefore the oil is rising. That is absolutely not true. I can have water, oil, anything inside a container and it be decreasing. I'm losing as long as I have stuff in there. It doesn't mean that if you do the integral, the gallons tell you. When they're asking if something is rising or falling, they're always asking about the rate. So what they're asking you is whether h of 6 or r of 6 is bigger. Am I gaining or losing faster, rising or falling? So you want to compare these. So if you substitute these in to your equation and find values, that's fine. But you can also just look at the graph of these two equations. And for me, this was the rate n, and the darker part was the rate out. So at time 6, right in here, looking at the values for each function, the rate out, r, was bigger than the rate n. So r of 6 is bigger than h of 6. So basically the out is bigger than the n. That means falling at t equal to 6 hours. We are not always losing more than we're gaining, so you want to make sure that you say at t equals 6 hours. So the answer was falling with the correct reason, that the rate out was bigger. Okay, now the next part is the part that actually asks how many gallons are in the tank. Okay, in the tank does include the initial value. So I have 125 gallons initially, plus how many I am changing. So the change is the integral of the rate n minus the rate out. Since adding and subtracting for derivatives and integrals is normal arithmetic. I do not have to do them separately. I can actually do it all at one time. So I can put this into one integral. My calculator is thinking. Okay, so we came up. So we came up with this value with the calculator. Remember, you have to put units and 3 decimal places because the question does not tell me to round. So 122.026 gallons. The next part asks us to find out when the volume of the tank is the least. This is an absolute minimum question, which means you have to do the extreme value theorem over the closed interval. So what we're looking for is the time t, we have to do the endpoints, and then we have to figure out the amount of oil. We know we start with 125 gallons. We know from part C that we end up with 122.026 gallons. And this is crucial. When you're doing a rate in, rate out question, the rate in equal to the rate out is always how we find our critical numbers. We look for those things and if the function is ever undefined. So if I'm looking at the graph from my calculator before, these functions are always defined, but we have 2 points of intersection where the rate in equals the rate out, meaning that the rate overall would be 0. So you have to, on your paper, indicate that you are doing the rate in equal to the rate out. You do not write down calculator notation about intersections. Okay, so I'm now going to look at my graph, and I'm going to ask the calculator to find the intersections. Okay, so I found one of them. I'm going to go and find the other intersection by repeating the process, but moving closer to that middle value. And whichever value I'm closest to is the one it's going to find. So I found my 2 points of intersection. Remember, I need at least 3 decimal places. I'm going to write down more because I don't want to round in the middle of my problem. And now we find the amount of oil here at these 2 times the same way we found the amount of oil in the previous part. We do the integral. So I can actually go onto my calculator and just clear out and change values on the integral that I had typed in previously. So I'm going to find the value at 4.7900015, and I'm also going to find the amount of oil at time 11.31847. Okay, so I'm going to drag those onto my paper for us to see. And so at time 4.790, I have 149.408 gallons. And then I have 120.738 gallons. So on here, I have to show how I'm getting my critical numbers. So I have to write down that I'm intersecting H1, HT, and RT. That does not mean I write down intersecting. I just have to say I'm setting them equal. I have to find those critical numbers. The table has to also check the endpoints. This is an extreme value problem on a closed interval. It's an abs max, abs min question. Okay, so now on here, the smallest amount of oil occurred. So at T equals 11.318 hours, comma, 120.738 gallons is the absolute min. So we have our answer, check, with the volume. We found the critical numbers the correct way, and the analysis that you have to show to prove that that's the minimum is that table of values. Okay, we are going to have to pause for now, and I'm going to save just the free response part.